Looking at our letter D here, so in this case, I only have to go to 2, which is nice, but I'm going to go up higher because this graph technically starts at 2, right? And then it should go up 2 and over 1. Is that correct? What you guys did? So our graph looks like that. And so our area under this curve, that's not a curve, is what shape? This is where the trapezoid comes in. So why would we use a rectangle or a triangle if we can use the area of a trapezoid? So again, that's how we did the warm-up we did. So it's base 1 plus base 2 times, I mean you can do half, but base 1 plus base 2 divided by 2 times the height. However, careful that the bases are not always on the top and the bottom. The bases are the parallel sides. So in this case, the bases go on each side here. So this is a base, and then that's our other base. So we have 2 plus, this one goes up to 6, right? And then our height would be the perpendicular distance across, which would be 2. Whoops. Does that make sense where I get those from? So we have 8 divided by 2 is 4, times 2 gives us 8 for our area. So that'd be our answer for this one. So all of the shapes should be something that are reasonable, that you guys should be able to figure out for the areas. Now the toughest one I think is going to be this last one. Did anyone figure out, I mean this kind of leads you into it because we haven't used it yet. It obviously has some form of circle. But being able to set up this formula or this graph without, like you maybe grabbed your graphing calculator to look at it, is we have to think about what this graph looks like, and I think it, kind of depends on your comfort level with this. So I'm going from 0 to 5. And I just started substituting values in. But again, I don't know where your comfort, like would that occur to you? I don't know. One of the things, so like I put it in, I'll put it in decimals. You guys have graphing calculators in front of you. I guess I could put it into our graphing calculator. Decimals is probably faster though. So we have square root of 25 minus x squared, right? So we're doing this from 0 to 5. If I put that on my graphing calculator on decimals, or if you do it in your graphing calculator, which you probably haven't had out since like first semester, 0 to 5 is going to be this like semicircle here, this sector. So we basically be finding the area of this space. So I know it's going to be a curve. I know it's going to have like a circular shape to it. And so using your like tools to know that, and just know that that's something that's going to happen, I'm going to substitute values in to figure this out. So if I put in, so I'm going to do a quick little table here. So if I'm unsure about the shape or I'm unsure about where things are going to show up, and I'll show you some of them will be nice numbers and others won't. So if I put 0 in, bless you, 0 squared is 0. Square root of 25 is just going to be 5. So 0, 5 is going to be my first point. The next couple are kind of icky numbers, so I'm going to skip them. I'm going to go to 3. 3 squared is 9. 25 minus 9 is 16, so this is going to be 4. Right? Yeah. So 1, 2, 3, 4. Then 4 squared is 16. 25 minus 16 is 9, so this is going to be 3. And then 5 is going to end up being 0. So hopefully you guys can draw some sort of curve, but realizing that this is a semicircle. There's a couple different ways you guys can do it. You can figure out how much of the total circle it is. Otherwise, you can do the angle at the center like we did in the warm-up. What's the angle at the center? 90. It's a 90-degree angle. So 90 out of 360, this is a quarter of a circle. Times pi r squared. Do we know what r is? R is 5, because the radius here, it goes out 5 in each direction. Now again, your book will leave it with pi in the answer, so they're going to leave this as 25 over 4 pi is a simplified fraction. I'm fine with it as a decimal. So that would be our approximate value for this integral. Seem reasonable? We're okay? So homework is listed there in the book for you guys. Again, just the little sketches are fine for your graphs. You don't have to get super fancy. Did I take a picture of the book? I don't know if it's in there now that I think about it. Did anyone? Yeah.